In this video, we are going to look into how to use TORA to solve some optimization problems based on simplex two-phase and BigM method. So first of all, to download TORA, you can go to this website pearson.co.in/mda taha, and there you are going to see this book, and you can access the students' resources. So when you click on it, you may have to create an account and log in. I have already logged in through my account. And then you see this downloadable resources. And then there you have this software support. So this will get you a RAR file. And when you unzip this RAR file, you're going to get this folder. So inside this software support, you have this install TORA. You can go through this readme documents. It has all the instructions how to install and use it. Once the installation is complete, you can open it, and you're going to see a screen like this. So you click here to enter. Next we need to decide what type of problem we are looking to solve. So right now we are looking to solve a linear programming problem, because this software can be used to solve several other types of problems as well. So when I click linear programming, it is going to ask you to whether you want to enter a new problem or select existing file, because when you enter a new problem you can save it in a file, so that can be opened for later use. This is regarding the notation of the numbers that you are going to see. So right now I have chosen this notation, decimal. So it will have 5 places pre-decimal and 2 places post-decimal. You can use this scientific notation as well, where you will see large numbers in powers of 10. So you can increase or decrease these numbers depending on the problem that you're looking to solve. Then finally we go to this input screen. So here you can enter title of the problem. So let me say trial, number of variables, and number of constraints. So let us look at some precise problem that we want to solve. So let us say I want to solve this exercise 7. So here number of variables are 3 and number of constraints are also 3. So 3 number of variables, 3 number of constraints, then I press enter. So as soon as you press enter, you are going to get this screen, variable names. Right now names are x1, x2, x3. You can enter other names as well if you wish. Otherwise you can proceed with these names. So right, so this is what you are going to have. So I want to enter this problem, exercise 7. So it's maximize 3x1, 2x2, 5x3. Constraint 1 is x1 plus x2 plus x3. It is of less than equals to type. You can type less than equals to from your keyboard, less than equals to 10. Second constraint 2x1, x2, 0x3, less than equals to 8. Third constraint x1, 3x2, 2x3, less than equals to 15. Then you have an option to choose lower bounds of your variables. So all my variables are greater than equals to 0. So these are the default lower bounds. If you wish, you can change it depending on the problems you're solving. And similarly, you have an option to choose upper bounds as well. So right now all the upper bounds are default, which is plus infinity. You can also mention if your any of your variable is unrestricted. So right now all my variables are greater than equals to 0. So I'm writing n for that. If any of the variable is unrestricted, you can type y instead of n. Now once you have entered your problem, you click on this solve menu. So when I click on solve, it is going to ask me to whether I wish to save this data. Let's say I wish to save this data, then I can save it in a file. So let me name it as exercise 7. So the same file can be opened at the beginning when we just start this software TORA. So When I click on save, I get this option: solve problem, view, modify, main menu, exit. So I want to solve this problem. It has three variables, so I can get algebraic solution. So now that we have two things, one is final solution. When I click on it, I'm just going to get the final solution, but I would like to see the iterations as well. So when I move my mouse over to iterations, it is going to show me these menus. So since all my inequalities were of less than equals to type, so my solution is going to be all slack starting solution. If you have other inequalities, then you have two choices: either M method or two phase method. The other two methods we are yet to discuss, so I'm not going into these two methods. So I click on this all slack starting solution, go to output screen. So again, it is asking me, how do you want to see your output? So I'm not changing these default values. So when I go to output screen, this is my initial simplex tableau. So these are the variables x1, x2, x3. It has added three new variables: sx4, sx5, sx6. These are all slack variables. If I want to go to the next iteration, I simply click next. So this green one is the incoming variable, and this red one is the outgoing variables. What you're seeing here, Z max is your Zj minus Cj values. So you have chosen negative most value over here, and you identify your incoming vector, and similarly this outgoing vector, and this will be the next iteration. If you want to see all iterations in one go, you simply click all iterations. This is going to show you all possible tables. It says that iteration 3 is optimal. So this is your optimal solution. Okay, so at optimality, x3 value is 5.5, x1 value is 4, and since x2 is not in the basis, that means it's a non-basic variable which is 0, and these are slack values, so we don't care about that. So this is how you solve all stack problem. Similarly, we can solve other types of problem as well. So I'm going to simply modify my data here. So let us solve another problem perhaps. So I go to the next section. So let us say I wish to solve this problem. Number of variables are again three. Number of constraints is also three. So I don't have to do any changes here. Objective function has changed, so it's 3x1 minus x2, so minus 1, minus x3, so minus 1. First constraint is x1, minus 2x2, x3 less than equals to 11. Second constraint, minus 4x1, x2, 2x3. It is of greater than equals to type. 3. Third constraint, minus 2x1, 0x2, 1x3. It's an equality. And this value is 1. All variables are non-negative, so I'm just choosing these default values. No variable is unrestricted, so everything is no. Then I click on solve menu. Let's say I save this data in the same file. Solve problem, algebraic. Now I cannot start with this all select starting solution. If I click it, it is going to show some error. Now I have two choices. One is M method, or second one is two-phase method. So let's say I go with two-phase method. Go to the output screen. Click on all iterations. So it's going to show me all the tables. So in 5 iterations, you are going to achieve optimal solution. So this is the initial phase 1 tableau. This is second iteration of phase 1, third iteration of phase 1, and then you move to phase 2, and in the second phase 2 table you get the required value. So when you are looking at this phase 2 tableau, you are seeing that this artificial variable rx6 and rx7, these are dropped. So if you recall, that's what we did in the class. So when we go from phase 1 to phase 2, we simply drop columns involving artificial variables. And this is your final solution. Yeah. So this is the last tableau. x1 is 4, x2 is 1, and x3 is 9. Function value is 2. So you can verify this solution with the lecture notes that I have provided to you. Similarly, you can solve it using big M method as well. So I go to solve problem, algebraic iterations, M method. I need to choose a value of M because I am solving this problem computationally. So 100 is a decent enough value because my coefficients were very small. So I click all iterations. So I'm going to get optimal solution in the fourth iteration. You can see the values of x1, x2, x3 here. So now we are going to discuss one more problem which involved cycling. So we had discussed this problem in the class. I have already saved it in a file. So I go to this linear programming, select existing file. This was question number 54 in the textbook. So I open it. This was the problem. Maximize 0.75, which was 3 by 4 x1 minus 20 x2, 1 by 2 x3 minus x4 with respect to these three constraints. Then I click on this solve menu. All the inequalities are of less than equals to type. So I'm going to select all slack starting solution. Uh, I'm going to leave this as it is. So if I click all iterations here, since this problem involves cycling, it is going to get stuck in an infinite loop. So I simply click on next iterations. So So if you look at your iteration number one, your basic variables are sx5, 6, and 7, and their values were 0, 0, and 1. If you look at the seventh iteration again, your basic variables are sx5, 6, 7, and values are 0, 0, and 1. So you are again back to the initial tableau, and then this process is going to be repeated indefinitely. And as you can see, this zj minus cj value is negative, so this tableau is not optimal. So none of the tableau will be optimal, and you will be stuck in an infinite loop. This is called cycling.